Welcome to The Explainer. So, back in 2013, a research paper described Bitcoin's core tech as a remarkable and elegant solution. Today, we're going to break down exactly what that means and, how it all works. All right, let's kick things off with the big problem Bitcoin was actually trying to solve. Think about it. In the real world, right, you can't give the same dollar bill to two different people. But with digital stuff, you can copy a file 1,000,000 times. So the huge question is, how do you stop someone from spending the same digital dollar twice? This is the famous double spend problem. And how do you do it without a bank or some central company watching over every single transaction? The way we normally handle this is by trusting institutions. Banks, credit card companies, you name it. They're the central gatekeepers who say, yep, this transaction is legit. But Bitcoin, it came along with this totally radical new system. The idea was to completely replace that trust in a third party with cryptographic proof. Basically, the whole philosophy shifted to trust the code, not the company. Okay, so how in the world does this trustless system actually pull it off? Well, it all kicks off with a really simple but kind of radical idea, a public ledger. And that ledger is what we call the blockchain. The best way to think about it is like a giant global digital notebook. It's shared with everyone in the network. Every single transaction gets announced and written down for the whole world to see. It's all out there in the open, which makes it totally transparent. So here's the play-by-play. Let's say you make a transaction. First, it gets broadcast to everyone on the network. Then, all these people participating in the network, we'll get to them later, they gather up a bunch of recent transactions and they bundle them together. In that bundle, that's what's called a block. But the real magic isn't just the block itself, it's how these blocks are all connected to each other. And that is the chain part of blockchain. See, each new block holds this unique digital fingerprint, it's called a hash, of the block that came right before it. This is what links them all together into this super secure chronological record. Now think about what that means. If you wanted to go back and mess with an old transaction, you wouldn't just have to change that one block. Oh no, you'd have to recalculate the hash for every single block that came after it. And that's pretty much impossible. Okay, so a public ledger is a great start for sure, but it kind of needs a security guard, right? I mean, if anyone can just add a block to the chain, what's stopping some bad actor from creating a fake one to, say, reverse a payment they just made? And this brings us right to the absolute core innovation of the whole system.
This is where the real genius of the system shines through. The paper we're looking at calls it the central focus of Bitcoin's entire design, and it's called Cryptographic Proof of Work.
Just like the paper highlights, this is the mechanism that finally lets us get rid of the bank as a middleman. Instead of putting your faith in some institution, the network puts its faith in two things: pure mathematics and the raw expenditure of real-world resources to make sure transactions are valid. So you can't just bundle up some transactions and call it a day. No way! To earn the right to add your block to the official chain, all these participants, and they're called miners, they have to compete against each other to solve an incredibly difficult computational puzzle. And this puzzle isn't hard by accident. It's designed that way. It's meant to take a massive amount of computing power and a ton of electricity to solve. That very effort, that's the work in proof of work. It's kind of like a global lottery where all these miners are just burning real-world energy to buy tickets for a chance to win. Now, here's the really clever part. Even though finding the answer to this puzzle is unbelievably hard, once some miner finally finds it, it's super, super easy for everyone else on the network to check it and say, yep, that's the right answer. And that correct answer, that's the proof that all that hard work was actually done. Okay, so you're probably thinking, wait a minute, why on earth would anyone spend all this money on powerful computers and rack up huge electricity bills just to solve some random puzzle, right? What's the incentive here? Well, this is where the economics of the system get really brilliant. It's got this built-in incentive model. The very first miner to solve that puzzle gets a reward, and it comes in two parts. First, they get a chunk of brand newly created Bitcoins. And second, they get to collect all the little transaction fees that users paid for the transactions inside that block. What's cool is that this reward system also controls how new Bitcoins are made. The code itself dictates that the reward gets cut in half roughly every 4 years. And there's a hard limit, a hard cap of only 21 million Bitcoins that will ever exist, period. So naturally, as the value of that reward started going up, so did the competition. The paper talks about how this kicked off a huge technological arms race. I mean, in the early days, you could mine with a regular computer processor, a CPU. Then people figured out that powerful graphics cards, GPUs, were way better. And by 2013, the game had totally changed. We saw the rise of these hyper-specialized chips called ASICs, which were designed to do one thing and one thing only: mine Bitcoin as fast as humanly possible.
And what's just wild to see here is the sheer scale of that growth. I mean, look at this data from just 2013 alone. You can see this exponential explosion in the total computing power, the hash rate, being pointed at the network. And here's the key. The security of the entire system depends on this massive, ever-growing wall of computational power.
But as elegant as this whole solution is, it wasn't seen as completely bulletproof. Even way back in 2013, the paper spent a lot of time analyzing the system's potential weak spots and vulnerabilities. So the research laid out a few different ways the system could be attacked. You had these big theoretical attacks on the blockchain itself, like clever ways to try and double spend. But there were also more direct threats to everyday users, things like malware, specifically designed to sniff out and steal the digital wallet files where people kept their coins.
But the big one, the one that really got discussed the most, was the 50% attack. Here's the idea. The whole network agrees that the longest blockchain is the true official one. So what if a single person or group got control of more than half of all the computing power? Well, in theory, they could start building their own secret, fraudulent chain and build it faster than the rest of the honest network. If they could pull that off, they could do things like spend some coins and then reverse that transaction, basically spending the same money twice.
All right, so we've looked at the mechanics, the money, and the risks. So what's the big takeaway? What's the really crucial point from this analysis way back in 2013? Well, the paper makes this almost prophetic conclusion. It says that the underlying technology, that cryptographic proof of work, is way, way more important than Bitcoin, the currency. The real game changer wasn't just digital cash, it was the decentralized engine that made it all possible. What we're really talking about here is a whole new way to create trust, a model for creating trust in a digital world, with total strangers, without needing a company or a government in the middle. It's like a blueprint for a system of verifiable, transparent truth. And you can imagine, that has applications that go way, way beyond just money.
And that leaves us with one last big question to chew on. By building a system where trust is basically outsourced to raw computation, maybe the most valuable thing Satoshi Nakamoto really gave us wasn't a new kind of money at all. Maybe it was a whole new way for us as a society to agree on what's true.